Designing power modules is complex, especially when transitioning from silicon to silicon carbide. Silicon carbide, known for its high efficiency, brings its own set of challenges, though.
Now, when it comes to the power modules, there's a lot of challenges in designing a power module. It's hard enough with regular silicon, but when you get to silicon carbide, it's even more difficult because it switches so quickly. You get this really high efficiency using silicon carbide, but it switches so fast that it will excite all the parasitics in the circuit, causing all this overshoot and ringing.
As we push the limits with silicon carbide, understanding its impact on circuit design is crucial.
You really have to know how to design it properly, and our power modules are designed so that the inductance on that gate drive circuit on the power loop is very low, so you can achieve that highest efficiency and highest power density. So we have that know-how to design these power modules with several devices connected in parallel. When you go with silicon carbide, it just switches so much faster. So for example, with silicon, you might switch at 5 or 10 volts per nanosecond. Silicon carbide can switch to 100 volts per nanosecond or even faster. And it's just going to be exciting circuitry, and what might have been maybe a 10 volt overshoot with silicon would be a 100 volt overshoot with silicon carbide, overstressing the device and damaging it. So you have to be more careful. There's a lot of benefits to it, but it's also a lot riskier. And that's where our gate drivers come in.
Luckily, innovations in technology offer solutions to these challenges. One such innovation is augmented switching.
We acquired a company called Agile Switch in 2019, and they developed a technology called augmented switching. And what that does is when you drive the MOSFET on, you drive the voltage from -5 volts up to 20 volts. With augmented switching, what we do is we introduce these intermediate steps. So going from -5 volts, we go to another voltage, which is programmable, and the duration is programmable. And then you go to your final voltage. And same thing at turn-off. You have these intermediate steps that are configurable. And that helps you really with the switching performance. So the DVDT and the DIDT will be, the overshoot will be minimized, less ringing, and you can have better EMI performance.
Silicon carbide and augmented switching are paving the way for future power modules, balancing efficiency with the intricacies of high-speed switching.